just put the dots by the ball.
Yeah, you put the dots by the ball.
No.
Oh.
And baby, baby,
It's connected. You said it didn't matter which way. It is connected. This is a positive, this is a negative.
Okay,
So
well,
they attract.
it would probably do so in a straight line.
It's still correct.
On the test?
Camera's on, by the way, but that'll work. I'm good with it. All right, now,
it's gonna make me cry.
Oh, wait, did y'all get that?
Yeah, it's
No,
yeah.
no,
Okay, go ahead. I got you.
what are you doing now?
Same thing.
Same thing.
Yes, other side. Can we put the lone pairs on the other side? On the, yeah. So it's giving the one by the bond, that's one.
No, I don't.
The one, yeah.
Actually,
I'm gonna get that one. Mr. Carroll, I need a high five for that.
Woo!
That's
Woo! Kato!
I need a high five. I got that one. But now, I feel like, but couldn't it, because you said there's like a lot
I've been taking
of.
like actually like decent legible notes in here lately.
Me too.
And in algebra.
He said that there's like a lot of things, like trillions of things
It
flying.
does feel like algebra.
So couldn't it be like that?
I mean, it
Really
could.
pre-cal is just kind of.
All right, yeah, let me go ahead and write that one down. But you know.
No.
I mean, technically, still got it
Right, okay.
I assume that's just
I just
two
wanted to just
hydrogen
do
chloride
that.
atoms bonded
Oh,
together,
sorry.
molecules bonded together, right?
Yep,
Okay.
not bonded, attracted.
Attracted.
Yeah, they like each other.
They're attracted. to
Just
each
like
other.
you and Dalen.
What is it?
What?
Kind
It's never over.
of like incest.
Mr. Wait, before you first said.
What?
Wait,
They're like
wait.
the same.
Oh,
Like,
wait.
hold on.
Everybody was talking about.
Mr. Carroll, I got a
Hydrogen
question.
chloride.
Because you like, well, look at it. It should be a straight line. If you think about it, if there's trillions, if there's trillions, because there's Mr. Carroll.
Got it. Good.
That. Whoa.
Yesterday,
What the heck was that?
Oh,
I
said
need
that
a
on camera.
reference.
Wait, we're on camera? Mr. Carroll, we're
Yeah.
on camera.
I said like in
Yeah,
reference
when
to
you were up there.
hydrogen chloride molecules. I said it's kind of like incest.
I gotta show
They're
my
like
grade.
attracted.
Why? Oh my
I said it again. Wow.
What in the world?
He's in one of these. He sees what I'm saying.
so yesterday, we left off with this, right?
C.
I think our question was,
What bond will be broken?
Stimulated.
It was, yeah.
When you got, I don't have my.
It's C.
all right, so here's what we're doing. We're doing, this is a distillation, okay? So let's define that.
It's not.
Oh, every day.
Okay. So a distillation is separating two or more substances that have different boiling points.
Yeah.
Okay, let me look right back here. Okay, so this is a very simple, this works, but it's not like, it's a lot more complicated if you're really doing this for real. But this is a simple distillation class, okay? If you had a mixture of liquids here that were miscible, okay? I got something else I can show you if they were immiscible, but if you had two miscible liquids, okay, such as ethanol and water, right? You had a mixture, and you poured it in here, okay? And you set this over some heat, and you heated it to above 78 degrees Celsius, okay? But kept the temperature below 100. So somewhere between 78 and 100. The ethanol is going to start to vaporize, but the water won't. So the ethanol vapors go up, but you have this sealed off, okay? You have a little stopper with a thermometer in there, so you measure the temperature. This would be closed off. And the ethanol vapors would be a gas, and it would go up the stack here. And then as it got away from the heat, it would cool, okay? And it would condense as a liquid. And as it goes back down, it would go down this tube and drip out into a separate container. And if you kept that going long enough, you would eventually separate out the ethanol and leave the water behind, okay? That's a distillation, all right? That's the way alcoholic drinks are made. The alcohol for alcoholic drinks are made. It's just a little more complicated than this, but not much. They run it through different things, and it purifies it a little better and stuff like that. But this is a simple little distillation flask. Okay? Yeah.
How does that work with distilled water?
Like distilled water, you just put water in it and boil the water off, and it'll leave all the. See how there's like a film on this? You can see that over there. Okay, that's because it's been allowed. There's stuff, residue left behind, various minerals and stuff. That's some kind of salts or something that's been left behind in here. Yep. So if you take water, just pure water, boil it, get it to 100, the water will separate and leave all the minerals behind that are naturally in water. So
That takes a long time.
not too long, not too
Oh, I
long.
mean, you know,
So I just want to just clarify, make sure that I understand. So basically, the reason why the ethanol went up is because you heated it to 78 degrees Celsius. The reason why the water stayed down is because it wasn't hot enough to boil yet.
Yeah.
Go ahead. Go ahead.
You breathed in the ethanol vapor, which you get from.
What?
I don't think so. Don't
Because
think,
that wouldn't get in your bloodstream.
I don't think the ethanol can get in your bloodstream that way.
Yeah.
I don't think, I don't
What
know.
is, what's going on? Something going on.
I don't
Something
know.
going on. We already know. We all know. Say hello to the camera.
So, now, if that's what's going on in here, okay, the question from yesterday was, what's being broken? A, B, C, or D?
A. Is it
C. Okay?
I thought it was.
Oh, it's like
Hey,
Sesame Street.
it was a post
sign.
It's like the Sesame
I
Street
knew.
song.
It's a Sesame Street question.
Oh my goodness, yes, okay, so that's what I
So,
thought.
if A is broken, then we don't have ethanol anymore, right? Okay? That would be decomposing the ethanol.
Okay.
Okay? If B is broken, you wouldn't have ethanol anymore. If D is broken, you wouldn't have any water. Okay? So all we're doing here is separating two or more substances. So there's no chemical reaction taking place here, right? So we're just overcoming, specifically here, hydrogen bonding and other dispersion those forces are being overcome because we're driving the kinetic energy of these molecules up, okay, to the point that they will vibrate away from each other.
Okay, so I see, okay, so whenever I think of A, I think about like the polar side and the non-polar side. So whenever you said that it might kind of like distills out for ethanol, it's just all, I'm thinking that the non-polar side goes with the polar
If you
water,
break
right?
A, it's not ethanol.
I mean, I know that, but I'm saying there's a polar side and there's a non-polar side. So why couldn't you look at it like, okay, look, if this is the polar side, and this is technically like it's connected to water, then why couldn't just that side, the non-polar side, be the one?
Because it would not be ethanol anymore.
I get, I mean,
Adding with.
I'm looking at, I'm just like, cause like, I thought it was A because I was like, but this is the non-polar side, this is the polar side. So if we're trying to distill out.
Newsflash, you're wrong.
That's
That's okay. Just accept it and move on, okay? A is not the right answer because A would be decomposing the molecule into something else. not separating it from a separate molecule. These are two separate molecules, right?
Yeah.
Two separate substances that are attracted to each other, but they're never going to
Yeah, they're
bond
never gonna
together.
bond,
They are
yeah.
not chemically
They're
bonded. Remember we said that no, we're not permanently dipoles, but remember we said that hydrogen bonding was the worst named thing in chemistry, right?
Yes, you said that, yes.
Because it's not a chemical bond.
It's like a
The
dash.
solid dash lines, the solid bars up here are all
Yeah.
chemical bonds. If you break any of these chemical bonds, then
Oh.
you're decomposing the substance. It's not ethanol anymore. It's a chemical change back to physical science, right?
Yes, yeah.
If you
I
break
didn't take
either of
physical science,
these,
but yeah.
it's not water anymore. It's
Okay.
something else. That would be a chemical decomposition of water.
Okay.
This would be a chemical decomposition of ethanol. It's not what we're doing. We're separating two or more substances, which means they're still the same substance after they've been separated.
Oh.
So we don't break any of these. We're
That was so.
overcoming that attraction.
I just wanna like,
Huh?
if they asked us to write on the test, like how we say, we just say, you can't separate A, B, or D because it would, yeah, but it's
Says
a chemical bond.
distillation is not a chemical process.
Okay.
Physical
That's
separation.
Distillation is not a chemical
It's a physical separation.
process. Wait, I'm trying to like, distillation or what?
Distillation
It's not
is not
a
a chemical
chemical process. He's gonna be so physical.
Look it up, apparently you actually get drunk like really quickly. Doing
What is
that
with
because
you
it
and
goes straight to your brain.
I think he
Okay.
wants to.
Do you
I think
like,
he just wants to.
Somebody type right now.
wait,
Y'all, which one is too late?
No, when he's 21.
Y'all, that's a little bit. This is like.
Wait, you said this like a physical who now? A physical separation.
Separation. Right there on the board. Okay?
A physical separation, not a
Physical
chemical.
separation, not a chemical reaction.
Wait, no, wait. Oh, this one.
are you okay?
Right. We got so much in this class.
Not a chemical.
You're not gonna cry.
Distillation is not a chemical reaction.
You scared of
It's
you
okay.
Do you ever see here like, it's like, why did I
We
do
just
that?
say, I know this is maybe this semester. We like sit and contemplate what we talked about in this class.
Oh, I'm gonna say you walking out.
No, I'm probably. Good question.
Yeah.
Like, you know, you said you babysit the next class, basically.
Sounds weird.
Yes, so like, do you ever go back and think about what we
You let
talked
me do
I
about?
try not to.
I didn't say.
Sometimes it's hard, you know? Sometimes you have a bad dream and you get up in the morning and it's like still kind of floating in your head, you know?
But we're
But
good.
usually
I don't think
about
this is a
mid-morning,
bad
you
dream. I
don't
think
remember
this is a
anymore, it
great
kind of
dream.
fades away.
But then we
I think this is a great
By
dream.
the time I get home in the evening, it's kind of fades out.
Do you take naps?
Do you know like
I don't have time.
I love naps. That's
The other day, I took a nap, and it was like
taking
one of those ones you wake up and you don't know your own name.
Yeah, I love what? I love my, listen, I love my summer naps when I'm laying on the couch. and I'm asleep, I wake up, where
best
am I?
naps are
What
when
am I
you
doing?
don't realize what
How long you been up?
Like break time?
Mr. Cadell, get it Mr. Cadell.
The other day, I
Yeah, you talk about us to the other day.
Or no.
Or what state? What happened to your state?
Oh, yeah, it's like Vegas.
I thought it was like a boring question.
Hey, it has to be your favorite
I was
class.
like,
No, it's interesting.
So could I also write, instead of separating the bond, C would leave the two substances?
Hold on.
Sure.
What?
When I first saw this, it's not important. I was like, that doesn't make sense because it's dark outside.
Mr. Kale, on them AP classroom videos, you know they be like, it'd be crazy. Just like their explanation, it don't be nothing like yours, like at all.
It's
Right.
probably the same thing, they just probably use different words.
That's why you should watch.
Oh, that's
it gives
just
you
more
different
complicated.
But no, like this one talked about like whenever, you know how we talked about how if it has more electrons, it's more polarizable, meaning that it has a stronger LEF. This one talked about
LDF.
LDF.
Oh, I never told you a single word. I didn't.
I thought you were talking about
Please,
IMF.
I did too. I was like, Elliot.
So then, but then on that one, it was like, it talked about the great surface area and all this type of stuff. The reason why that it was linear.
Okay, write this down.
It's weird.
Oh, I
Wait, what? Now, have you watched that one? Yeah,
I watched that great.
yeah, and I look at it, I'm like, what the world?
What do you write?
Okay, kinetic molecular theory, here we go.
Do I need to write down like?
Yes,
Okay.
yes, write this down.
He's so.
Okay, but you know, you did say you love our class. Yeah, but you said you would rather have our class that's talking about chemistry for
Love is
30 years
strong
straight,
word.
over and over and over.
Hey.
That's what you said.
Don't require, say what?
I'll cry.
I'm just saying.
I mean, you don't love our class.
I just said it was a strong word.
It's somewhere.
Now she's trying to.
He's trying to
You
guess
know
why
what's
this
a
guy.
strong word?
What's that?
Shoot it, is there?
Marty, what's that?
I'm not cornball.
Are you in something?
Mr.
That's
Mr.
better
Mr.
for like self-study.
Oh, I saw
for
that.
students
Yeah.
that
Yes,
found,
what does
like,
it say?
So-
found your accounts.
You don't want this?
Yeah,
Are you
like,
in
trying
it?
to watch the basic
Yeah.
chemistry.
Yeah.
Mr. Hale, tell me you gotta please.
Dalen said it before.
Wait, there's
The
another
sodium
one.
fine one.
Y'all.
Oh, are you
NA?
NA?
Oh.
Hey,
Hey,
Mary.
Mary?
Lori, sorry.
Mary.
You know, my life's kind of sad whenever I look forward to coming to AP chemistry and anything else in my day.
Honestly.
Oh, we did.
I'm
Brad,
proud.
you didn't.
No way.
I promise I know.
This is really bad.
You're bad.
Maybe I don't have 2020 vision.
Oh, I know you know. I know you know.
Okay, can you please read that?
Substances
Oh my
are
gosh,
made of
substances are
particles.
made of particles?
No.
No.
No, wait.
I did not know.
What's a particle?
Particle.
That's the guy from.
She's been telling you.
No, it's
All right, there we go. Write that down real quick, Mike.
I remember.
No, I gotta find another one. I know I saw another one somewhere.
Oh, did we look at this on this and like, we just like wrote that down? I'm pretty sure, yeah.
It's possible.
We should have
Can I
a
do
quiz on
this?
this and just like.
We should like have a whole test on this, and it should be like worth like five.
All right, next little fun fact here.
Wait, let me finish it first.
Brain emotion.
Okay, how's everyone doing?
Mine's been okay.
But yours-
Brayden, if I hear one thing about drinking, you're good, boy. No more incest, no more drinking. We're done.
What?
Incest, we're talking about incest.
No.
I think incest.
Can somebody please read number 3 aloud?
They're always colliding with each other and the walls of their container.
What is that book around Miss Jackson?
Oh, the
Oh.
100 years of solitude.
Yes, bro, that was scary.
We got like 100 pages in. It's just next to it.
All right,
I never read it.
Imagine 100 pages.
I'm
your favorite
Y'all never read it.
all right, here we go. Temperature is directly proportional to the kinetic energy of particles. Okay? Kinetic energy
What?
is equal to half of the mass times its velocity squared. Okay? All right, that's where the saying heat 'em up, speed 'em up comes from. Okay, so that's not, though, that is not a appropriate thing to put as an
I might just
explanation.
have to. I don't think.
So what the explanation is that temperature is directly proportional to kinetic energy, which is equal to velocity. It's a function of velocity.
So you
Wow.
said that instead of heat 'em up, speed 'em up?
Yes, don't say heat 'em up, speed 'em up. You need to remember heat 'em up. It's like dissolves like. You need to remember that, but that's not the proper explanation. Heat 'em up, speed 'em up. You need to remember that. Things get harder, they move faster. But the proper way to say it is that temperature is directly proportional to kinetic energy, which is a function of velocity.
What? Okay, wait a minute.
I'm literally reading what's on the board.
You said.
You said one other thing that was.
Yeah, you said
on the board.
Well,
function of
y'all took
velocity.
math class, right? So kinetic energy equals 1/2 mass times velocity squared. That means kinetic energy is a function of velocity.
Oh, you talking about the formula.
Okay, well, just look, what I say, we're not done, we need to reassure.
That's it. That's it.
Temperature is directly proportional to the kinetic energy of particles. That is a function of
Velocity.
It is correct.
That is a function of.
It is
See,
correct.
you will see. You added
It is.
wrong.
It's
I
making
didn't
sure.
add
Come up with that, but
Wait, don't fast forward it.
Right.
Tell me that pause.
And this
So
is,
you
that's the
know,
explanation.
Get irritated, wait.
That's the explanation if they ask, why does it get faster?
Because
What I
it's
just said.
No, because I said I need reassurance.
One more time.
Temperature is.
It's because it's that. It's
The kinetic energy of particles.
This is why you
Because kinetic energy is a function of velocity. That's what that little V is right there, velocity.
This is why you won't
Hey,
go
and
by
what's
and
Mr.
say crazy little things.
What's all right about it's, that's what we use if they say, why does this go
Yes,
faster?
that's what we're talking about.
If we were just like,
Equals, why
really
does it go faster?
would you like
I
absolutely?
think you write all your thoughts on paper.
I haven't
Like, you
yet.
write your thoughts on paper.
You
I feel
know,
like
your
you're
status
there.
student?
Yeah.
Really?
I just asked them out loud.
Oh, you do seem like.
Yeah, oh, yeah.
You seem like you do that.
Yeah, that's like, oh,
I got
Give me, look, give me about a minute.
because I already know I'm gonna ask them some questions. I will agree.
Give me a minute, give me a minute, give me a minute, wait, wait,
What are we
wait.
still doing?
I'm writing.
He likes to write slow.
It's not speed up. I have to like, think about it.
I can't even write that.
I'm good now.
Here we go.
They gotta look,
Wait.
that's voltage.
Yeah, they gotta look good,
I gotta be able to read that slow. What is it?
What is that?
They say me and Max are the winner.
You're Max Boltzmann?
Yeah, we go way back. No, before you even born. Before you.
Okay, this graph right here, this is called a Boltzmann distribution or a Maxwell Boltzmann distribution, depending on if you want to give credit to both guys or not, okay?
Both or both?
It's on there.
It's not on the test. The name of it's not on the test. All right, so here we go.
Here we go.
Are you familiar with a bell curve?
Yes.
Have y'all taken any statistics at all?
No.
This is algebra.
technically we did, but-
Algebra two with statistics. I think that's the name of the class.
But I don't remember learning. I don't remember that.
No, huh?
Can you draw?
Who teaches algebra two and statistics? Y'all didn't discuss any normal
Caleb,
distribution.
Get up
in
there,
that class.
Caleb, get up there, write it down, you get it, you don't next.
I don't think we took
like-
on one statistic. Oh, wait, yeah, we did.
Oh,
We did
yeah,
not like
but-
that.
Yeah, can you just draw one up
Mr.
there?
Ketta just
That
had
is
it
his
in
name.
Draw
A.
one up there now.
Up there now.
You can't be like, okay, hey, well, y'all know what a bell graph is, and then be like,
So like,
oh, there's
even,
one wrong.
clearly I know it, because I didn't.
I mean,
Right,
Okay,
I didn't
so-
know what was that.
A normal distribution. So if we gave it to, in theory, okay, for example, this is commonly seen in testing, okay? This is a bit of a small group to have a normal distribution, but if you had enough people taking a test, okay? Let's say you had a college class, 200 people in it, right? Then the theory is that a normal distribution of human beings in a class, if you have enough data points, the grade should be normally distributed, which means the majority of people should make an average score, and the further you get away from average, the fewer people you will have. Does that make sense?
Yes.
Okay, so average is average. Okay, And the further you get away from average, the smaller the distribution is, right? The smaller the number of data points that fall in the ranges that are far away from average. So if you have a college professor who grades on a curve, as they say, okay, it means they take all the tests and they put them on a curve, which means the most people are going to make a C, some people are going to make B's and D's, and a few people make A's and F's, okay? So the highest few grades in the room make A's, the next group make a B, the middle group, which will have the largest number of people, will make a C, and then the same number of people that made a B will make a D, and the same number of people that made an A will make an F. That's called grading on a curve, okay? All right, now, particles in a sample. So right now, we just want to look at the solid line curve right here, the solid curve, okay? This represents helium at 100 degrees Celsius, okay? I'm sorry, minus 100 degrees Celsius, sorry. Helium at negative 100 degrees Celsius, okay? There is a speed right down the middle of this curve of about 1,000 meters per second. No, that's probably about 800 meters per second, okay? Most of the helium particles have that velocity, that speed, thereabouts, okay? The further you get away from that speed, the fewer particles have those speeds. But they're not zero until you get down to zero or way out here. So kinetic energy being proportional to velocity, we need to clarify that a little bit. It's the average velocity, okay? Average velocity. Not every particle. Do I?
You said like what is average velocity?
No. I said that when we say that temperature is proportional to kinetic energy,
Okay.
it's the average kinetic energy and the average velocity. So in a sample of helium at negative 100 degrees, every helium atom does not have the same kinetic energy. Okay? They've got an average kinetic energy in which most of the helium atoms are close to that value, but there are some that are way off of that value. Some are way down here, some are way over here. Okay? So that gives a curve distribution. It's in statistics what they would call a right skewed curve. We don't have to know that, okay? Because it's not a perfect bell. If you notice, it's not perfectly symmetrical, right? It's got a little tail over here to it, okay? That's called being right skewed. You don't have to know that, okay? What we do have to know is that if you heat this from negative 100 up to 100, we heat them up, what? Speed them up. So the curve shifts, okay? This distribution curve shifts over. The peak, the top of the curve, is now at a higher velocity. It went from about 800 to about 1400, okay? So the average kinetic energy and therefore the average velocity of the helium particles increased. But there's overlap here, right? Some of them have this speed way over here. Some of them still have slow speeds over here. But the average has increased, okay? If you heat it up another 400 degrees, up to 500 degrees, the curve shifts over again. Now your average speed is almost 2,000, about 1,800. Notice that the distribution widens out. So the slower they move, the narrower the distribution is. The faster they're moving, the wider the distribution. Okay? Now, what would they ask you on the test? Okay? If this were not given over here, okay, ignore these numbers over here. Fair question would be to say, which one of these peaks represents the helium sample at the highest temperature? It's the one that has the highest average speed, right? Which is this one. So that would be the, I can't repeat everything I say in here, unless they extend this class to like August of next year. So, okay, which one of these is the highest temperature?
The one that's well, the one that's lower,
The one that's,
not as steep.
the one that's shifted further to the right.
Okay, so that one.
Okay, so it's the speed of the particles that relates to the temperature, right? So higher temperature means higher speed. This curve has the highest average speed. Okay, so Boltzmann distribution graph number 1 is that they could ask you about is where they give you same substance at different temperatures. Okay, everybody with me on that? There's another way they might present this. They could give you different substances at the same temperature. Okay. Now, all right, these are the Boltzmann distributions for the noble gases, all at the same temperature. Okay, who do we think would be moving the fastest? Helium. Why? Why? What is helium? Is what? Why would it move faster at the same temperature? No, it does not. 2 electrons. No. Yes, but why? Why would helium be the fastest?
Because its particle speed is.
Now we've been to a track meet.
Yes.
Been to a track meet,
Yes.
right? Okay. All right. So, pick on here. If any of our current offensive linemen entered the 100-meter dash, do you think they would win?
No.
Okay. Why not?
Because they're wider.
Because they're big, right?
Yes.
They ain't going to win the 100-meter dash. All the linemen that play that on track team, they're down there throwing javelins and frisbees and stuff, whatever, the discus and stuff, right? I can't remember now. Okay. So why do you think helium is the fastest? It's the smallest. Okay, it's the smallest. Which one do you think would be the slowest of the noble gases if they're all at the same temperature? Xenon. Why? It's the biggest. Okay. So if we look here, the peaks are shifting to the right as the particles get smaller. This is over here on the right. This is helium, then neon, then argon, then krypton, then xenon. So this is a graph of different substances at the same temperature. What can you tell by this? You can decide which one's bigger and which one's smaller. The previous graph was same substance, different temperatures. What you tell by that is which one's moving faster at different temperatures. Down here, you see that you could determine which substance is the smallest or the largest, based off the fact that they're being held at the same temperature, but they're not moving at the same speed.
And the other one, it was different substances at different temperatures.
Nope, same substance at different temperature. Okay, those are Boltzmann distributions.
Are these on in the classroom? I mean, not the Google Slide that you post.
Okay, good with that? Boltzmann distribution. I don't know what else we're supposed to do today. Let me look at this.
We may need to start.
I may need to try to get a head start when I'm.
What is now? And drink. You want the alcohol, just drink some alcohol.
All right, yeah, we're gonna start gas laws tomorrow, so watch tonight, please watch these videos, okay? We also have a quiz tomorrow on the particle diagrams, right? So make sure we can do that. Watch the video about gas laws. Should be mostly reviewed from last year, hopefully. Okay, we'll start discussing that tomorrow. Camera is off.